Hello students. Today let's discuss about the topic fluidized beds. My name is Abhilash GK and I am working as an assistant professor at the Department of Mechanical Engineering, Al-Azhar College of Engineering and Polytechnic, Thodupuzha. Let's get to the topic. What is fluidization? Fluidization is an operation by which fine solids are transformed into fluid-like state through contact with the gas or liquid. Fluidization refers to the gas solids and liquid solid systems in which the solid phase is subjected to behave more or less like a fluid by the upwelling current of gas or liquid stream moving through the bed of solid particles. When fluidizing sand with water, the particles move apart and their motion becomes more vigorous as the velocity is increased. But the bed density at a given velocity is same in all directions of the bed. This is called particulate fluidization and is characterized by a large but uniform expansion of the bed at high velocities. Beds of solids fluidized with air usually exhibit what is called aggressive or bubbling fluidization. During the process, the gas passes through the bed as bubbles or voids, which are almost free as solids, and only a small fraction of the gas flows in the channels between the particles. Let's now discuss how fluidization works. First, we discuss about how fluidization works and then we go to the topic of the fluidized beds. I know you all are concerned about how fluidized bed works, but first let's study how fluidization works. When a gas flow is introduced through the bottom of the bed of solid particles, it will move upwards through the bed through the empty spaces between the particles. At low gas velocities, aerodynamic drag on each particle is also low, and thus the bed remains in a fixed state. Increasing the velocity, the aerodynamic drag forces will begin to counteract the gravitational forces. This causes the bed to expand in volume as the particles move away from each other. Further increasing the velocity, it will reach a critical value at which the upward drag forces will be exactly equal to the downward gravitational forces, causing the particles to become suspended within the fluid. At this critical value, the bed is said to be fluidized and will exhibit fluidic behavior. By further increasing gas velocity, the bulk density of the bed will continue to decrease and its fluidization becomes more violent until the particle no longer form a bed and are conveyed upwards by the gas flow. When fluidized, a bed of solid particles will behave as a fluid, like a liquid or gas, like a water in a bucket. We take the analogy water in a bucket because a fluidized bed expresses certain behavior like a water in a bucket. That is, the bed will conform to the volume of the chamber. The surface will become perpendicular to gravity. The surface means the bed surface. Whatever angular the bottom surface of the bed is, the top surface of the bed will always become perpendicular to gravity. Objects with lower density than the bed density will float on the surface, while objects with higher density sink to the bottom. The fluidic behavior allows the particles to be transported like a fluid channeled through pipes not requiring mechanical transport. That is very important because for coarse particles such as sand, transportation is a very big problem. Using mechanically transporting those coarse particles is very difficult. By using this fluidic behavior, you can transport those coarse particles through small distances using this behavior by using fluidized beds, by using channeling the coarse particles through pipes. The intense mixing within a fluidized bed means that its temperature is uniform. There is excellent heat transfer between a fluidized bed and heat exchangers immersed in blood. This property, that is excellent heat transfer between a fluidized bed and heat exchangers, is used in many of the applications that we have about to see. Now, up to this point, we had discussed about how fluidization works, and we just touched how a fluidized bed works. I just said it how a fluidized bed works, but we shall look into the topic very detailed here. A fluidized bed is formed when a quantity of a solid particulate substance, usually present in a holding vessel, is placed under appropriate conditions to cause a solid fluid mixture to behave as a fluid. This is usually achieved by the introduction of pressurized fluid through the particulate medium. This results in the medium then having many properties and characteristics of normal fluids, such as the ability to free flow under gravity or to be pumped using fluid type technologies. The resulting phenomenon is called fluidization. When trying to describe the operation of a fluidized bed, one main definition is the minimum fluidization velocity. This parameter is defined as the superficial fluid velocity at which the upward drag forces exerted by the fluid is equal to the apparent weight of the particles of the bed. This concept has been discussed earlier, that the upward drag force exerted by the fluid is equal to the downward gravitational force. So that velocity is that velocity of the fluid moving upward is the minimum fluidization velocity. Another common characteristics of fluidized beds is the bed expansion. When fluidization is achieved, fluid flowing upwards pushes the particles up and separation distance between the particles increases. This increases the void volume within the bed of particles and the bed is considered expanded. Types of fluidized beds. There are 6 types of fluidized beds. I don't know it is safe to say that it is types of fluidized beds or it is stages of fluidized beds, because each type of fluidized bed is a different stage of velocity of the flow. We shall discuss in the slide that 6 types of fluidized beds are fixed bed, minimum fluidization, bubbling bed, slugging bed, turbulent bed, and pneumatic transport. First one is fixed bed. Fixed bed is when the upward motion of the gas is very less. In the minimum fluidization, the upward velocity of the gas is increased and the bed is expanded. In a bubbling bed, small air pockets or bubbles of gases go through the expanded bed. Inside the gas bubbles, there will be no coarse material, only gases. That is a bubbling bed. In a slugging bed, these gas bubbles collapse and become a continuous gas volume, and it moves upwards. That's a slugging bed. In a turbulent bed, there will be large amount of gas bubbles, and it will bubble as an uncontrollable manner. And in a pneumatic transport, the bed is considered fully expanded and it goes through the flow in the direction of the flow. The coarse material go through the flow in the direction of the flow. In this mode, we could transport the coarse material through channeled pipes. Okay. Application of fluidized beds. Physical processes include drying, mixing, granulation, coating, heating, and cooling. These processes take advantage of the excellent mixing capabilities of the fluidized bed. One of the most important applications is the drying of solids. Fluidized beds are often used to cool particulate solids following a reaction. Cooling may be fluidizing air alone or by use of cooling water passing through tubes immersed in beds. Fluidized bed combustion. Fuel particles are suspended in a hot, bubbling fluidity bed of ash and other particles such as sand, limestone, etc., through which jets of air are blown to provide the oxygen required for combustion or gasification. The resultant fast and intimate mixing of gas and solids promote rapid heat transfer and chemical reactions within the bed. In this way, we are uh, combining the fluidized bed with the combustion of a fluid, or combustion of a solid. Actually, we can efficiently combust a solid using combining the process of combustion to a fluidized bed, because the fluidized bed provides efficient mixing of the oxygen which is inside the air and the fuel particles in the fuel. Solid fuels such as coal can be combusted very efficiently using this method. We are about to study it in the coming slides. Limestone is used to precipitate out sulfate during compression, which also allows more efficient heat transfer from the boiler to the apparatus used to capture the heat energy, usually water tubes. There are two reasons for the rapid increase of fluidized bed combustion in combustors. Possibility of using fuels which are difficult to burn using other technologies. Possibility of achieving during combustion a low emission of nitric oxides, and the possibility of removing sulfur in a simple manner by using limestone as a bed material. There are two types of fluidized bed combustion. First one is bubbling fluidized bed combustion. Second one is circulating fluidized bed combustion. From the figure, we can see that in a bubbling fluidized bed combustion, the fluidized bed is subjected to a flow of primary air, and that air bubbles through the fuel, through the bed material, or in this case coal actually, and then combustion takes place at the at the fuel side, and flue gases move upwards, and flue gases only fuel gases go through the exhaust pipe. Now, in a circulating fluidized bed combustion, a distinction between the bed and freeboard area is no longer applicable. A large fraction of particles rises up the bed and is recirculated. This is a schematic diagram of a coal combustion. Here, a coal and limestone is fed into a fluidized bed, and fluidizing air is pumped from the bottom. Thus, a fluidized bed is created, and combustion takes place inside the fluidized bed. Some steam is generated by running steel pipes through the fluidized bed, and also we also run steam pipes through the flue gas in order to take advantage of the heat of the exhaust gases coming out of the fluidized bed. The small quantity of fuel that goes through the flue gas is collected at the dust collector and it is recirculated, and the flue gas goes through the goes on the way to the exhaust pipe, reheats the intake air, preheats the intake air. The intake air is preheated, and that heated air is supplied to the fluidized bed. This is a picture of a fluidized bed in an industrial setup. Advantages and disadvantages of fluidized bed. Advantages. A fluidized bed is compact, simple in construction and easily scalable. High thermal efficiency, continuous operation and ease of process control due to stable conditions. These are the advantages of fluidized bed. Disadvantages. Non-uniform flow patterns, that is difficulty to predict. Agglomeration of particles decrease effective surface area. That is, the particles just tend to stick onto each other, and those bulk and the particles become more like a sluggish, like a bulk of small bulk of particles, and it will decrease the effective surface area of the fuel or the particles. Possible of breakage into fine particles. Bed wall erosion. That all we can safely assume that these types of bed can erode the bed walls very quickly. Thank you all for listening to me.